Analytical geometry. In this video, we are going to learn about the gradient of a line. So when you talk about a gradient of a line, we are talking about the slope of the line to the horizontal. So what do I mean about a slope to the horizontal? Let's say, for example, we have a horizontal line. If you have a line that is also horizontal, therefore this line is not going to have any slope to the horizontal because the angle between the horizontal line and this line of ours is going to be 0 degrees. So therefore there is no slope. So the slope means that you have an angle to the horizontal line. For example, if you have this line like this line is going to have an angle to the horizontal line. Therefore, this line is going to have a slope. You can also have a line that is moving like this. So this line here is also having an angle to the horizontal. Therefore, it has a slope. You can also have a vertical line. This line, it is having an angle, but now it is having a special angle to the horizontal line, which is 90 degrees. So this line that is vertical is not going to have a slope. You are going to see that when we define the slope. So now, we said that the line that is horizontally is not going to have the slope. Therefore, the gradient is 0. But now, if we have a line that is increasing, this line is going to have a positive gradient. So an increasing line is a line that when we move from left to right, it is going up. So therefore, this line is increasing, hence it has a positive gradient. But now, if we look at this line here, as we move from left to right, the line is going down. So this line is a decreasing line, and therefore the gradient of the line is going to be negative. Like I said, if you have a vertical line, we are not going to have any gradient. The gradient of a vertical line is not applicable. The equation of a gradient is given as the gradient is the change in y values divided by the change in x values. So when you talk about change, we talk about the final y value minus the initial y value, all divided by final x value minus the initial x value. So this is the equation of the gradient. So let us see that if what we are talking about will make sense. So if we look at the first scenario here, if you have a horizontal line, this will mean that you are having a specific y value to be constant. Remember, when you have a Cartesian plane, and then you have a line that is horizontally, for example, if this point of y is 2 here, therefore this line is going to have the value of y as 2 throughout. The value of x will be changing, but now the value of y will be the same throughout, but the values of x are going to change as the line goes. So now, in a horizontal line, the values of y is the same. So now, if the values of y are the same, therefore we are not going to have a change in y because the y values are not changing. For a horizontal line, the y values are not changing. Therefore, this is going to be 0 all over whatever values that we can get for x2 minus x1. So it doesn't matter what values we get, but now 0 divided by anything is equivalent to 0. Hence, we say the gradient of a horizontal line is equivalent to 0. So let us look at the second scenario. On the second scenario, we are having an increasing line. So let's assume that we have the following coordinates to say now this point of A here and the point of B, it is having the following coordinates. We have -2 is to -3. We can say this one is 2 is to 4. So now, if you have the coordinates of a line, then you will be able to determine the gradient of that line. But first you need to label your points to say now this is your point 1, therefore you're going to have x1 and y1. This is your point 2, you're going to have x2 and y2. So for us to determine the gradient of this line, we are going to substitute the value of y2, which is 4, and the value of y1, which is -3. And then we're going to substitute the value of x2, which is 2, minus the value of x1, which is -2. So the gradient of this line here is going to be 4 plus 3, which is 7, and then 2 plus 2, which is going to be 4. So therefore, we can clearly see that the gradient of the line is positive. So if you have an increasing line, the gradient is going to be positive. So let us look at another scenario where we have a decreasing gradient. So let's say now the coordinates of this point here, which is going to be C and D, are as follows. So let's say the coordinates of D is -2 is to 4, but now the coordinates of D here is 2 is to -3. So with the following coordinates, we'll be able to determine the gradient of the line CD. So now the gradient is going to be what? We have to label our points first. So this is going to be our x1, y1, x2, y2. So then we'll be able to do what? To determine the gradient. So the value of y2 is -3 minus the value of y1, which is 4, all divided by the value of x2, which is 2, and the value of x1, which is -2. So now if we evaluate this, we are going to have -3 minus 4, which is going to give us -7. And we are going to have 2 plus 2, which is going to give us 4. Therefore, we can clearly see that our gradient is going to be a negative value. So this proves that if you have a decreasing line, therefore the gradient is going to be a negative gradient. So let's say, for example, we want to look at what? At the vertical line. So remember, if you have a vertical line on a Cartesian plane, if you have a vertical line, that means now the value of x is the same through the line. But now the value of y will change as much as it can, but the value of x will be the same. So now what is going to happen is that if you put any values of y, for example, y2 minus y1, the values of x are going to be what? Are going to be 0 because the value of x is the same throughout. So 2 minus 2 or 3 minus 3 is going to be 0. So now if you have a 0 as the denominator, therefore this gradient is going to be undefined. So that is why the gradient of a vertical line is undefined. So with this being understood, we will be able to learn about the gradients. So the first thing that we need to know is that if we have parallel lines, line AB parallel to line CD, therefore the gradient of the two lines are going to be the same. So this means the gradient of AB will be equal to the gradient of CD because the lines are parallel. And the other important law is that if you have perpendicular lines, So if this line is perpendicular to this line, therefore, what is going to happen is that, let's say this is line A, B, and this is CD. The product of the gradients of perpendicular lines is always equivalent to -1. So the gradient of AB multiplied by the gradient of CD will have to be -1. So these are the two most important scenarios that you need to understand so that you get the gradient correct. So in this video, we are going to stop there and then we will discuss everything as we go on. Thank you very much.